1.6, other types of equations. So it should not be new to you that we're going to be doing a lot of solving today, like we've done in the past. There are two x's there, so that means we have to set this equal to 0. So first I have to move this over because there's x to the fourth and x squared. We can't just simply start solving this. We have to subtract that over. So now always look first. What do they have in common that you can take out? Well, 48 is divisible by 3. I can take out a 3, and they're both divisible by x squared. So what do I have left over? I have x squared minus 16. Once you factor, then you see if you, or once you see what they have in common to take out, then you look to see if you can factor this further. And because of this squared right here, I should be able to factor this further. And by golly gee jeepers, I can. What two numbers multiply to get negative 16 that add together to get 0? Bing, bada, boom. So we set all of those equal to 0 then, and you solve to figure out what are the solutions to the problem. So we have 3 solutions. 0 has a multiplicity of 2 because this one happens 2 times. These are vocab words that you should have remembered in your previous math course. I would subtract the 4 over and I would add the 4 here. Pause the video and try to do B by yourself. Now this is where sometimes people get kind of frustrated. They assume that the second one's going to be just like the first one, and it's not always the case. However, you can still factor this out. This then becomes just a equation that we have worked with in the previous section. We can solve this. Add the 4, divide by 3, take the square root. The only thing you have to remember is at this point right here, we have a plus or minus. Because remember, my degree here is 4. I should have 4 zeros. Here I have a multiplicity of 2, and then there's 2 more zeros here. That's a total of 4 zeros. Next, when you're doing these problems, you should always first see if you can factor anything out. Fortunately, we don't have anything to factor out here. So now whenever there's an x cubed, x squared, x, and a constant like so, we can factor by grouping. Remember how to factor by grouping. We group the first 2, we group the second 2, and we see, okay, what do these have in common? This has an x squared in common. If I were to take out this x squared, I'd be left with x minus 3. What do these two have in common? Notice I'm not putting a plus there at all. What do these have in common? These have a 3 in common, leaving me with an x minus 3. So when I factor by grouping, now 1, because these match, these have to match, 1 is an x minus 3, and the other, we put the 2 totals together. You should always be able to check this because, again, we're not changing our degree at all. We have a degree of 3. We have to make sure that this is still a degree of 3. There's 1, 2, 3 x's there, so this would be a degree of 3 still. Now, again, we can set these equal to 0 and solve. And the one that we always have to make sure that we do not forget is when we, right here. When we take the square root of that, we need to have our plus or minus 3. I want you to try to do B and C by yourself. So the first one, your answer should have been 5 and plus or minus the square root of 2. Again, pause the work if you want to see how I factored by grouping. The second one, they had a 3x in common. So again, that's where you should always be looking first. What do they have in common that you can take out? Once I took out that 3x, then it's factoring my quadratic just like what we have done many times before in the past. And I got 2x plus 3 and x minus 6. So example 3, what's different? When I'm looking at example 3 compared to example 2, what's different? Well, this had a degree of 3, that's a degree of 4. That's a big difference. If we look though, it's kind of nice because in this degree of 4, it's going down by degrees of 2. So we're going down by 4, 2, 0. When this happens, we can still split this into 2 binomials, just like how we factored up here. So I'm still going to split up this x to the fourth. As long as when I multiply these two together, this x squared times x squared, I get x to the fourth, that works. And then my middle two have to add up with an x squared, so that works. So I'm thinking what multiplies to get positive 2 adds together to get negative 3 would be negative 1 and negative 2. So I set both of these equal to 0 and solve. Again, the biggest thing that you cannot forget, this one actually, people People get this question wrong a lot because they do this. They take the square root and they're like, oh, yep, I know I have my positive, negative, square root 2 there. Bam. They take the square root and they go, yep, I know I have my positive, negative, square root 1. Square root 1. Square root 1 is 1. So whenever you can, you should simplify. So that would be my final answer right there. I want you to pause the video and try to do B by yourself. So for B, you should have gotten x equals positive negative 2 and positive negative square root 3. And for C, when I factor this, sometimes people get a little bit more like, oh my gosh, how do I factor that? This is what it looks like factored. X squared minus 4, I would add the 4, take the square root, that's a 2, positive, negative, remember the 2 points. When I take the square root of 1/9, the square root of 1 is 1. The square root of 9 is 3. So positive, negative for both of those. Okay, so if you look at the next page, this is all things that you have done before, 100%. But for these questions, I feel like there's a lot more of me talking. So we're going to do these 3 examples, example 4, 5, and 6 in class. However, if you feel that you know what you're doing on them, you should do them by yourself to show me how amazing you are. Other than that, have a wonderful day.